want to go towards the what? It wants to go towards the left. Yes or no? It wants to go towards the left now. Right? So it's like, you know, I think some of you have been to a situation in life that when you want to fix something, something gone wrong elsewhere. Exactly the same as this. So when that's the case, for point B to stop moving in the X direction, you need a reaction over here. Right? So this is your BCX. And BCX happen to be also your FBC. Right? So from here, we do static analysis again. So positive is going towards the right. Summation about forces in the X direction is equal to 0. So you have ABX, so you have minus ABX, right? Plus by BCX is equal to 0. So BCX is equal to what? ABX. Okay, so this is also equal to your FAB. Okay, so when you do this calculation, usually you'll know the angle over here. You'll know the angle over there. So the angle over there is usually known as theta. Okay, so from here, how is member AB and BC going to react? Okay, so now you draw your members now. Okay, so this is your member AB. And next, this is your member BC.
Sorry, sir. Shouldn't it be BCX is equal to ABX is equal to FBC?
Oh yeah, FBC. Who are you? Where are you?
I'm right here.
Okay, I owe you a pint of alcohol, okay, beer.
I don't drink.
Then orange juice then, okay? Orange juice is more expensive. Thank you.
Thank you.
Okay. So this is your BC. Okay. So to look at the structure now, right? To look at the structure now, the members now, okay, we have to apply, okay, to find out if members, okay, hold on, let me change mode. Okay, so to find the members are under tensile or compression, okay, we have to apply Newton's third law. Anyone? Newton's third law? What does Newton's third law say?
Every action, there's a reaction of equal magnitude but a different direction.
Action equals reaction. Same in what?
Opposite direction.
Same in magnitude. Different what?
Opposite direction.
Or opposite direction. Okay, I take your word. You're right. Opposite direction. Well done. Right? So when we apply Newton's third law, what did we say? Action equal to what? Reaction. Same in direction. Same in magnitude. Different in what? Direction. So opposite in direction, same magnitude. Right? So if we look at FBC, at point B is going towards there. So action is equal to what? Reaction. So from here, you can see that point AB, member AB is under what? Tensile. Member BC is under what? Compression when you apply Newton's third law. Are we clear? Okay. So this is on thrust analysis. Okay. Okay. we're going to look at another example. Okay, if I cannot finish this example, I will do a 1 hour recorded tutorial to complete this example. Okay, now let's look at example number 2 now. Anyone, any questions with trust analysis, please? Anyone? No questions so far. Looks familiar. Good. Okay, so the next one we're going to do at example number 2. Again, if I cannot finish the example, I will do a tutorial, and I hope I'll upload the video on the tutorial. I hope you will watch it. Okay.
And sir, I just want to double check and make sure, but these notes you're writing, they're going to be uploaded onto Avenue.
Yeah, absolutely. You know, if you guys are paying what $1,000 on this, if I don't upload the notes, it's not worth $1,000, is it? Hello.
All right. Thank you.
Right. Okay. It's expensive. Once it's expensive, it has to have the quality. Yes. Teaching online is 3 times more work for me than teaching face to face. I'll tell you that. Okay, 3 times more work. And you guys will say, yeah, it's 3 times more difficult for you guys. Am I right? No reaction. Everyone gone quiet.
Right.
Yes.
Right? Yeah, I knew it, you cheeky sort, right? Yeah. Everyone is in the losing end. Wait. Everyone is in losing end in this, okay? My purpose is to make sure that when you finish this course, you are competent in this topic, okay? That's I'm not accountable to you, by the way. I'm accountable to society. What do I mean by that? I'm accountable to society is such that when you finish my course, okay, someone hire you to do structure analysis, you can do it, okay? I'm answerable to society. I'm not answerable to you, okay? If you can do it, good. If you pass and you can't do it, yeah. I cannot answer to society, can I? Okay, so that's my take on it. That's why I'm putting in so much effort. Okay. Enough of pet talk. Right. Question number 6 now. This is a question given in a PO exam. Okay, in a PO exam, you will see a structure like this. Okay, so I know this structure, all of a sudden you see things like this, you're like, holy, what is this now? Okay, it's known as a gradient distributed load. And I'll teach you how to do this. Okay, and there's nothing to fear. It's all math. Okay, it's nothing to fear. It's all math. Okay, now let's look at this problem. So a rigid bar. Okay, so there are a few things that I want to highlight down here. Is when they use the word rigid bar. Okay, so the rigid bar ABC is supported by a 20 millimeters pin at point A. Right, so they give us the pin at point A, and 12 millimeters diameter cable at point B and C. The cable at B has a length of 4 meters, and the cable at C has a length of 2 meters. Both cables are made of steel with a yield strength of what? 400 megapascal. Right. Interesting, right? They did not give us what? Ultimate strength. They give us what? Yield strength. Yes or no? Any idea why? Anyone?
Because you don't want the cable to deform.
Yeah. And it's because steel is what? Is it a brittle or ductile?
It's ductile.
Yeah. It's ductile. That's why if you're going to calculate factor of safety, it's going to be based on his what? Yield strength, right? It's not going to be based on his what? Ultimate. However, if they were to mention that this is made of concrete, right? They can give you either the ultimate or the what? The yield. Because the difference in the ultimate or yield is not a lot. Yes or no? Right? So now, as an engineer now, you have an in-depth understanding why those values are given. Am I right? Okay, better understanding now than before. Okay. So the elasticity of modulus is 200 megapascal. The bar is loaded with a triangle distributed load that has a maximum intensity of 20 kilonewton. I will explain to you what all this means. Okay, so don't panic yet. Two turns up the bar plus a concentrated load of 25 kilonewton at the top of the bar at point C. So this is where we are. Okay. So the first part is find the forces developed in each cable. Okay, so we're going to find the forces at each cable. And then we're going to find the corresponding horizontal displacement at the top of the bar at point C. So we're going to find the, well, and then at C is, I will not, it's not in this course that I teach C, but I will do it also. So find the shearing stress in the pin at A, given that the pin is located with a double shear configuration. Okay, we will do all of them. If I cannot finish, I will do a tutorial on this, and you have to watch the video. Okay, why am I doing this? Why is it important? Because for your homework, right, you have question very similar like this. Okay, so for your homework, it's not as difficult, okay, but you need to have components to understand. Right.
Sorry.
Yeah.
You said that we are not gonna learn the question C on these course.
Yeah,
Okay.
but I'll teach you how to do it. Okay, so
Okay.
in the exams or term test, I will not test you for it. I want you to know. But it's so easy. Okay, it's just force divided by area. That's it. Okay.
Okay.
Okay. So we're going to find the forces. So find the forces. So we are given that diameter at point A, right, is equal to 20 millimeters. So convert to meters. So 0.02 meters, right? And the diameter of cable B and the diameter of cable C, they're the same. They are at 0.012 meters. So that's what we know. And then we found that the length of cable B is equal to 4 meters. And the length of cable C is equal to what? 2 meters. So this one. And then we are also given that the stress yield, capital Y is usually yield. So it's 400 times 10 to the power 6 Pascal, right? So that's what we know. And then we are given that Young's modulus is equal to 200 times 10 to the power 9. Okay. But first thing I want to highlight is, what do they mean? Can someone explain to me what do we mean by a rigid bar? Right? They say ABC is a what? It's a rigid bar. What do they actually mean? Anyone?
Means it won't deform or bend.
Say it again.
It won't deform or bend.
It will deform, but it will not bend. Hello?
Okay, yeah.
Okay. So rigid means the structure will deform or will only deform in a straight manner. What do I mean by that? Okay, what do I mean by that? So this is our member. Okay, so I'm going to draw our member. Okay, this is our member A, B. So B is what? The B dimension is what? 6 and 3. So B, and this is C. Okay. So when the structure deform, right? The structure